Good morning, students. Today we are carry forward our memory as we have discussed in an earlier class. Today we are having the memory bit calculations. And what is memory bit calculations? You can see that in our general life you are using some words like 0, 1, on, off, yes, no, true, false. They all are work like 0, 1. 0 means that is false and 1 means that is true. Okay, generally this language is called machine language. This is called machine language. In computer this is called binary language. Which language? Binary. As you earlier studied that thing in your science class, that what is the meaning of binary. Binary means 2. Now students, what happened when we are working on the system? So here this one is we are user, and user is generally called humanware. Okay, so this is human, and the human give the instruction to the computer system. So this computer system take the instruction and then convert them in the machine language, or you can say in binary language. Okay, and then after converting them it gives the output here. Okay, so this will be the output. What language they are using for the instruction, in the same language they are using the output. Okay, so this is users language and this is also users language. Means I take the input from users language, they give the output in users language, but the users language understood by the computer system. Okay, then it converts in the machine language or binary language and then gives the result to the user. Now how it can be possible? How can it possible? That for that one we have to study something like first when we are having ANSI. Student, first time the computer is generated by Americans. So in America there is an institute that's name is American National Standard Institute that generate the computer and their computer languages. Okay, so this language is developed by ANSI, American National Standard Institute, and this American National Standard Institute create a code. That code is called ASCII. Which code? ASCII code, ASCII, and the full form of ASCII is American Standard Code for Information Interchange. American Standard Code for Information Interchange. Okay, like that one, if Americans develop this thing, then we Indian also develop, and that code is called ISCII, Indian Standard Code for Information Interchange. Then what requirement to change the information like that? And in India there is 22 languages in our constitution. So according to constitution, everybody wants to convert their instruction to their own language. For that, in today's life we are using Unicode. Which code? Unicode we are using, and this Unicode is called universal code. Then what is the difference between this universal code and this ASCII code? Because this ASCII code is 7-bit. कितना bit है? 7-bit. Okay, and this Unicode is 8-bit. So this will take the more data than the 7-bit code. But nowadays mostly we are using 7-bit ASCII code. Okay, then how the machine is working, how the user's instruction are changed in machine code, we will discuss about it. Okay, let's see that. Students, first we will discuss about the ASCII characters. ASCII characters. ASCII characters means the characters provided by the Americans to the world. As we know that we study about we very well know that about the keyboard. Okay, so on the keyboard we are having the keys are there. Okay, you can see that the keyboard, and this keyboard generally called QRT. Which keyboard? QRT keyboard. Why its name is QRT keyboard? Because it's a sequence of characters. You can see that one Q, W, and E, R, T, Y. Okay, so that's why its name is QRT keyboard. Okay, on that keyboard we are having all the alphabets are there. Okay, A to Z, all the alphabets here we can see that all the alphabets are there, A to Z. Then we are having the numbers. Okay, these are the numbers 1 to 0. Okay, these are the numbers. So mostly we required only the numbers and the characters. Remaining thing are the symbols. Numbers and the characters means what their ASCII value. We will discuss about that one. Okay, so for that we are having one ASCII table. In ASCII table we are having all the numbers that is converted. You can see that on the screen. Okay, okay, you can see that the screen over here. Okay, like a is on 65, then 66, B means the capital A to Z, capital A to Z. Z is the last character and Z is the last character that is here. Okay, on 90, you know that this is 90. So capital A is start from 65 and the last capital Z ends on 90. Okay, and then here are some brackets. Okay, square bracket, then divide, then close square bracket, and these all are. And then small a start with 97 and ends on 122. So this is small z 122. Like that, we are here having the numerals also, numerical values. So you can see that 48 start with 0. So 40 means 0 has the ASCII value 48. Okay, so 48, 49, 50, and the last character is 57 means 9. So I said that 0 to 9 all the values between 48 to 57, and remaining all the symbols you can see over here. Okay, like here 32 for space, or exclamatory word we are having 33, then double quotation 34, and then 35 for hash we are having 35, 36, then this, all things are here. Okay, so not more useful for us, but these three things are useful for us. What these three things? First is A to Z. What one? A to Z. So age ASCII value is 65 and Z ASCII value is 90. So between A to Z all the 26 characters are there. Okay, now the small, then 97 to small a and 122 or small z, all the 26 characters are there. Then for the numbers, so for the numbers we are having then 48 to 57, all the 10 numbers are there. Okay, so mostly we will use them, and what is their use we will discuss about that. Okay, let's see that. If you are writing your name, like suppose your name is RAM, your name is RAM. Okay, so here first the computer will find R, then A, and then M, because it is in capital. So it will first find its ASCII value. What value? ASCII value. So R's ASCII value is, we will go that if A has ASCII value 65, then R always comes on N15, O15, P16, Q17, or R18, means R on 18. So because R placed on 18 and A placed on 65, so we have to less 1 over there. So 8 and 4, 2, Okay, 6, 7, 8. On 82 we are having R. Let's see that if A is on 65, then B, okay, then C, then D, then E, F, G, H, I, J, K, L, M, N, sorry, O, P, Q, R. Okay, so let's see that. We will write that one. So 65, then 66, 7, 8, 9, and 70, then 71, 2, 3, 4, 75, 6, 7, 8, 9, 80, then 81 and 82. This is 82. Okay, so my answer is correct. Like that one, we can calculate every value of ASCII characters. Okay, like that small. So R is on 82, then A is on 65, R is on 82, A is on 65, and M is 13, means M on 77, because M placed on 13, M placed on 13th place, so 64 plus 13, 77. So these are the ASCII values of this one and this one and this 65. Okay, so we can find the ASCII value of these characters. Okay, now students, we can convert them in the binary language also. Like suppose you are having 65. Okay, we want to create 0 1 0 1 0, then which language you want to create? Binary. Okay, or binary language, that is called 0 or 1, means by means 2, by means 2. So if a number is divided by 2 and its remainder we will write here. So this is 32, remainder is 1, then 32 is divided by 2, remainder is 0, then 16 is divided by 2, remainder is 0, then 8 divided by 2, remainder is 0, 4 divided by 2, remainder is 0, and then 2 divided by 2, remainder is 0, and in the last we are having 1. Okay, so we will write it from down to up, this binary number, and this binary we are writing here. First we are having G1, then we'll write 0, so 0 0 0 0 1 2 3 4 5, 5 zeros are there and the 1. This number is binary number. Which number it is? It is binary number. And this number is decimal number. Which number? Decimal number. Okay, so we can find the actual answer of this one. So you know that is this is 0, then this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Total number of elements are 6, and we want to find that what was the number in decimal form, so we can convert it. Okay, so this is our base. 2 is the base of this number, so this 2 into this is our value 1. Okay, and this binary number has power 6. Okay, then remaining all are 0. Okay, so their all values answer is 0, so plus, remaining all are 0, so plus kiya. Okay, now here you can see that base is 2 is multiplied with 0 and its power is 0, so this is 1. This is 1. You know very well that this is 64, so 64 equals to 65. What type of number it is? it is the decimal number. So you know that if a number has power 0, sorry, 2 into 1. If a number has power 0, then this number converts automatically in 1. Okay, sorry, power on this number. Okay, sorry. Power on this number, so this number in 1 into 1, so answer is 1. And 2 has power 66, then 64. Okay, so 65 again, means we are starting from 65 and we are again calculated 65. So any number we can calculate on the basis of decimal conversion of decimal to binary, decimal to binary. We can do that one. Okay, next thing we'll discuss in the next class. Thank you.